Hello, everyone. Great to be here towards the end of the day. Hopefully, folks are not too tired. So I'm here to talk a little bit about speech recognition and where we think it's going to go over the next, 8 to 10 years, let's say by 2030. A little bit about me. My name is Dan Kokotov. I'm a co-founder of VP Engineering at Rev. I lead the teams that are working on our speech recognition engine. Before I kind of get started, why are we talking about this? Why speech recognition? Why, of all the problems in AI, focus on that one?
Our world is full of ideas worth spreading, stories worth telling.
OK, that was a random slide that was inserted just to trip me up. But yeah, why speech recognition? Well, it's kind of like what the slide says. What we have here is a failure to communicate. Ironically, in today's world, even though we have so many more ways to communicate than ever before, it's almost too many ways and too much communication, and the noise is drowning the signal, so to speak. And so that's why we at Rev, our mission, our vision is to understand every human voice and make some sense out of all this noise. And this is a big vision. This is something we expect to be working on for certainly more than the next 10 years. But we hope to make some pretty good progress over the next 10 years. And there's a lot in that phrase, right? So every voice means in every language, with every accent, for people of all backgrounds, talking in all contexts. And understand, of course, to begin with means to get the words from the audio, but then it's to capture the meaning and the context and to be able to do something with those things. So with that said, before we kind of talk about the future, always kind of useful to talk a little bit about the past and understand where, the history of it is. We always kind of can say that we stand on the shoulders of giants. So who are those giants? Well, we pretty much have been trying to teach computers how to understand speech from almost the beginning that we've had computers, right? Like the first computer, ENIAC, everyone's probably seen like those big refrigerators, right? That was created in 1946, and by 1952 we had Audrey, I think it's the first speech recognition system from Bell Labs, could recognize 9 digits with 90% accuracy. Maybe not super impressive by today's standards, it probably was almost like a miracle to the people back then. And by 1962, we were up to 16 words. So I guess at the beginning, progress wasn't particularly fast. And progress kind of remained steady but slow over the next few decades. But there started to be real applications. We got up to thousands of words with a system called Harpy from CMU. DARPA started investing a lot in this area. And so it kind of became bigger vocabulary, more applications, kind of a big breakthrough. In the 1980s, people started to use statistical approaches to speech recognition and something called HMMs, hidden Markov models. That was kind of a big increase in the capabilities of these systems and kind of proved a data-driven approach. But then it was really in the last 2 decades that we kind of went from gradually to suddenly with these changes. And kind of a few milestones worth calling out. In 2009, the Kaldi speech recognition toolkit was created by a guy named Daniel Povey. This was a big deal because this was really the first open source toolkit that could be used to create real systems. And so kind of allowed a lot more people to contribute to the field. In 2011, Siri launched on the iPhone, and that was really when speech recognition became something mainstream. Everyone kind of suddenly started talking to their phone, and soon enough to Alexas in their home, and now I think kids are basically born expecting to do this. And then it was really in the last few years that a combination of powerful GPUs that can train much larger models and this kind of Cambrian explosion of new neural network techniques and deep learning techniques really moved the state of the art forward and kind of raised our expectations of what's possible. So, kind of to summarize how we were able to make progress. Many reasons, of course, but these are kind of like a couple of the key ones. The combination of deep neural networks and more powerful GPUs really raised the bar of what a system could be capable of. Kind of widely available cloud computing, so we could run these things. And then this combination of open source toolkits, open source data sets, pre-trained models that really reduced the barrier to entry in the field and allowed many more people to participate. And it's kind of all like a virtual cycle, right? Like as more people contribute, more progress gets made, other people get excited, they build tools to make the stuff go. So that's all nice, but we're not kind of there in the promised land yet, right? There's still a lot of things to work on. These are kind of like a few of the ones that we're not there yet, and they'll kind of dovetail with where we think we could get to in the next 10 years. So one, broad language coverage and mixed language recognition, right? Like, so English is pretty good, actually. Like, we can do a pretty good job for a lot of use cases. Maybe like French and German, a couple of the other big ones. But really, once you start getting into that longer tail of languages, the quality drops off dramatically. And then if you're kind of mixing languages, then it's almost like a non-starter today. Speech recognition at scale, and what I mean is kind of like the expectation that most audio and video that's produced will be transcribed. Selective things are, but not most things. Downstream tools that make full use of rich outputs. Right now, most speech recognition APIs, they produce a fairly simple output, right? It's like a transcript. And as a result, there's a limited set of things you can do with that. We think, and I'll get into it, that when these APIs are capable of creating a richer output, more things can be done. And finally, the supervision of ASR by humans, our training process is still sort of fairly simplistic, right? We gather data, we train the model, then we try to improve it with new data, but the process can be dramatically accelerated. So almost to the good part of the talk, but before kind of like making our predictions, let's see how like the last time we tried to predict this, how it went. And this is kind of like where the title of the talk came from. In 1993, these two guys published this article with the speech recognition the next 25 years, which actually was referring to a previous article that a researcher from Bell Labs published in 1960s. And at that point, quite like sensibly, in 1960s, he was pretty skeptical and that this was going to go anywhere. By 1993, they were fairly optimistic, and they thought that speech recognition actually could have lots of commercial applications. And they actually did pretty well. As is usually the case, they might have missed on the timing, but they actually got a lot of things right. I won't call out all of them. I think he made like 8 predictions. But a couple of ones, he talked about major advances will be made in language modeling. Well, you could argue like language modeling is the success story of like the recent years, right? Like we've all kind of like seen the cool things people can do with GPT-3. One that maybe wasn't quite so good was speech recognition over telephone connections will continue to be the most important market segment. And I guess we still all have to deal with those somewhat like unreliable voice prompt systems, but I don't think that's what most people any longer think of when they think of speech rec. So I'm not as ambitious as, I guess, this person. I'm not going to try to predict 25 years. I'll limit myself to a 10-year time frame. So what are like 5 things I wanted to talk about? Multilingual models, rich transcript outputs, speech recognition at scale, a better kind of collaboration between humans and machines, and finally, and this is one that kind of, I think, ties it all for me, is responsible AI. So kind of let's go a little bit more in depth on each of those things. So multilingual models, I kind of teed this up, right? This is, I think, the next frontier for making really big progress for those kind of lower resource languages as well as for mixed language circumstances. This is where the new emerging kind of end-to-end techniques will really help us. I think with hybrid approaches that were more popular earlier, this was more difficult, right? Like you kind of needed language models that were specific to each language, lexicons and so on. So for languages that didn't have much data, it was more difficult to make progress. With end-to-end techniques and new kind of transfer learning techniques that people are putting a lot of effort into, this is becoming much more possible. You can really start with a model trained for English and really fine-tune it for another language with not that much data. And similarly kind of train these multilingual models that take advantage of the similarities between languages. So this is really exciting, kind of bringing the benefits of speech rec to a lot more people around the world. Rich transcripts. So kind of have a picture here of, this is like a lattice, which is a common kind of a result of a decoding by a speech recognition. But this is not what's typically returned from a speech rec API. Usually a speech rec API, maybe it'll return the one best transcript with maybe confidence scores to say how confident it is about those guesses. Maybe n best, so it'll kind of tell you one or two more next possibilities. But as you kind of can see here, the full sort of reality is much more rich. And if we start returning these things from our speech recognition API, then downstream tools like editors, search tools, et cetera, they can do a lot more, right? They can let you, if you're editing the transcript, you can kind of have autocomplete that is based on these lattices. You can do a much smarter search, things like this. So one of the challenges will be to figure out how to pass these things back and forth in a standard way, in an efficient way. But I think once we do, a lot more things will happen. ASR at scale. As it says here, I think people will really start expecting that every audio and video they participate in or consume will eventually be transcribed, will be accessible, searchable, and actionable. And there's so much audio being produced these days. There's new live social audio tools like Callin or Clubhouse, right? We all listen to podcasts. We all participate in meetings. But generally speaking, it's really difficult to find those things after you, when you go back. All the time I want to try to find something I heard in a podcast, and you can't unless that specific podcast has transcripts. But that's not the case right now. I think in the future, this will be the case. And not only will we have transcripts, but we will actually have those downstream things, maybe key insights, key moments from those audios and videos that people can find. Humans and machines. So you might think from the previous one, the ASR at scale, that okay, it'll be all automated, right? The machine use case will cover everything. And while I think increasingly ASR will cover more and more of use cases, there will continue to be a role for humans for a long time still. And what is that role? Well, there's a couple of things. The most obvious one is you'll need humans still to cover the most difficult use cases, the hard to hear things and stuff like that. They'll always exist. The second one is for something we call human in the loop training. So it's back to what I was talking about earlier, where right now kind of it's a simplistic cycle of training a model, then doing another training cycle. With human in the loop, we think it can be accelerated quite a bit. You can kind of imagine where a human reviewing the results might say okay, this particular time the model did badly for maybe this particular audio environment. So I'm going to tweak it a little bit. I'm going to tell it to use more data from that type of audio. And as a result, the model improves, and you can continue iterating. So it's kind of a quicker feedback loop. And the last point is the humans are really the ones that need to ensure that the speech recognition system behaves in a way that adheres to these responsible AI principles. And there's a lot that goes into responsible AI. It's obviously a very buzzwordy thing, but I'll just kind of focus on these few things here, and I'll go into each of them a little bit more. Responsible AI systems need to be fair, explainable, privacy-respecting, and accountable. And we really think that more and more companies that work in AI will follow these principles because, kind of with great power comes great responsibility, right? Like as AI grows more powerful and as people kind of rely on it to do more and more things, we're going to expect it to behave in this way because it's kind of impacting our lives more and more. So the first one, FAIR. A FAIR ASR system recognizes the spoken word from everyone, everywhere, regardless of these various attributes, right? Like what the speaker's background is, what their socioeconomic status is, what their demographic characteristics are, and so on. And in order to do that, we have to reduce the bias in our models. And in order to do that, and that's the hardest part, is to detect the bias. So how do we do that? Well, we need sort of, first of all, a lot of metadata about our training data. And we need the right infrastructure and pipelines to be able to test our systems for this bias, to be able to easily kind of adjust the training data mix and kind of iterate on that. And it's not a one-time thing, right? It's something you have to be vigilant about. This one is probably kind of the hardest, right? Like the biggest goal, explainable. Explainable AI systems can provide, when requested, explanation of data used, collection, and processing on the model's performances and outputs. And this is sort of like the dark side of our neural network revolution, right? Our AI has gotten more powerful, but it's harder and harder to kind of understand why it comes up with the answers it does. It's sort of a black box. And it's hard to solve, but one of the ways we could make progress is back to the previous point about richer outputs. The model can produce more than just the words, in the case of ASR specifically, right? The model could say, well, I thought the speaker had this accent, or I thought the speaker was talking in this kind of environment. I thought the volume was low. And so when maybe the system makes a mistake, the tools that are downstream of the ASR system could actually explain to the user, this is why kind of it came up with the answer it did. And if the user corrects it, then kind of that can be fed back into the system. Privacy respecting, obviously, very important to all of us as more and more of our data, in a sense, gets scooped up. Clearly, we're trusted by people with this data, and we have to be good stewards of it. But even in a sense more important, we have to make sure that the model does not expose or leak the way in which it was trained. And kind of like maybe one example of this that people saw is when GitHub released its model where they can do code autocompletion. People kind of quickly figured out they could trick it to expose what stuff it was trained on with fairly simple prompt hacking. So in that case, it's probably not a huge deal because it was trained on open source repositories anyways. So I don't think, if I remember correctly, any real private data was exposed. But in the case of things like speech rec or speaker identification and these kinds of things, the stakes are much higher. So we have to be much more careful. And the last one, this is kind of the one that brings teeth, in a sense, to the other three, right? Because this is making sure that the system's output is actually monitored and that it does adhere to these principles. And otherwise, it kind of doesn't really matter if you try to do the other three. And again, this just requires a commitment of resources and infrastructure to building those monitoring systems and taking actions on them. So just as a final kind of thought, I wanted to describe one use case for us, for Rev, with speech recognition, kind of where we are today and the ways that it would evolve, if these few things that I talked about come to life. So Axon, I don't know if you guys know about this company. They're the largest manufacturer of body cam equipment and other tools for police departments around the country. And of course, we kind of all learned over the last year and a half how important that stuff is, right? We've probably seen more Axon body cam videos on YouTube than ever before. But it's back to that failure to communicate, right? This is really the thing that allows the truth of those interactions to be captured. And they're helping police officers file better reports, better information to the public, and stuff like that using Rev's speech recognition. And it's extremely valuable today But I think it can be even better tomorrow if all those things come to pass, right? The amount of video they're capturing is exponentially growing, right? So we really need ASR at scale to deal with it. They certainly have to deal with mixed language speech, right? The types of people they deal with. So, getting mixed language speech or those low resource languages is going to be very important. Real-time monitoring is maybe not as directly linked to the other stuff, but what they'd like to do is react much more quickly. Right now, they're mostly using it to kind of enable fast, easier reporting by the police officers, but eventually you can kind of imagine where people might take action on those things right away. And that's where those richer outputs that I mentioned before can really help with that. And of course, they are laser focused on eliminating bias. There's essentially, in what they do, there is no room for error. So they're certainly on board with responsible AI. And that's it. That's kind of my thoughts. And we have a booth. Feel free to stop by, talk to me, or I have a bunch of colleagues here who are also excited to talk about speech rec.
Thank you, Dan. Oh, if you can wait for a second, do we have any questions? Come up to the microphone. I have one for you. Sorry.
Sure.
Actually, I have a comment and a question.
Yeah.
One, you mentioned, you were talking about the different languages, how some had been advanced as far as a lot of different speech recognition, English, French, German, Spanish probably.
Yeah.
One thing that we found that was, in our research, was that the reason those long-tail languages don't work is because it's a market, the addressable market is small. So, you get some countries that are very small, that have specific languages for them. There's just not enough business to work it. Did you find that to be true?
Yeah, definitely. Yeah. And in a sense, that's why those kind of transfer learning techniques and other things are so important, right? Because you're not going to be able to collect, thousands of hours, right?
Right.
Or to train a separate language model for each of those languages, right? It's just economically not practical, right?
Right, which makes sense. So my question to you is about speed and accuracy. If you kind of the evolution of speech recognition, and you talk about speed and accuracy, and I want to be clear about speech to text versus other models like, I'm going to throw my words out there and just correct me, but word to vec, phrase to vec. So can you talk about that a little bit and just talk about the evolution of accuracy and speed and what speech recognition can do now and how you guys see it moving forward?
Sure. Well, in a sense, they are kind of trade-offs, right? And you can kind of push on one and you can push on the other. And of course, ideally, as computing power increases, you can go on both. But I think it's really about the use cases, right? And for some use cases, it's better to have a bigger model, right, and take longer, right, but produce something more accurate. In other cases, you need the answer right away, right? If you're talking to Siri, you're not going to wait more than a second, right?
Right.
On the other hand, if you are transcribing an earnings call, well, you're probably okay, running the model for a little bit longer if you're going to get a more accurate result. So that's how I think about it.
Well, I mean, as far as Rev customers, what would you say they're kind of leaning towards these days? As far as is it speed, is it accuracy, is it is there?
Yeah, it's a good question. Again, I think it depends. We have ones that need both. Kind of our claim to fame is to have the most accurate speech recognition engine for this kind of long form video. So on balance, I would say accuracy is more important to more of them. But that said, we still have others who really need it right away as well. So it really varies by use case.
Got it. Okay, very good. Thank you, Dan. We appreciate it.
Thank you.